Hey all, welcome back to my channel. So in today's video we are going to talk about FSM, which is final statement. We are going to write a code for this FSM in Verilog. Okay, in order to write a code, you should have a state diagram and state table for that. So that is why what we are going to do is we will be taking a sequence as an example and we'll be drawing the state diagram and state table for it. And then for that particular code only, we will be going to write a code for that particular sequence only. We will be writing a code in Verilog. Okay, so that is what this session is about. So, coming to FSM, before going into all these things, let us first have a brief discussion on what is FSM. This is for those who don't know about FSM and all. Okay, I just want to give you a brief example on this FSM. Okay, if you already know about FSM and everything, you can skip this part. Okay, before going into the topic, if you are someone new to this channel, consider subscribing this channel and hit on the notification bell also. Also follow me on all social media handles. Also I have a telegram channel where I will be uploading some questions or assignment types. Okay, and you can also ask doubts about this any concepts in that particular channel. Okay, you can I'll be leaving the link is in my description box. You can go and join there, right? So coming to FSMs, finite state machines. So we will use this finite state machines in many places, like many programmers or many mathematicians and many professional fields also use this FSM. So what is this FSM? What does it do? So basically FSM is used in order to describe any system or any design which is having some limited conditional states. Okay, that means whenever any system that you are having is having any limited conditional states, then okay, then we'll be using FSM at such points. So let me give you a small example for this so that you'll easily understand about what is FSM. Let us consider that we are designing some a cleaning robot. Okay, so when it comes to robot which is designed for cleaning purpose, it will be working under certain states. Is it or not? For example, its first state will be ideal, and then the robot should move. Yes, and then it should clean, and then it should mop. Okay, and there may be certain obstructions while it is moving or else like that. So at such cases it should decide what it should do, like it should move to left or it should move to right. So in this way it is having some limited conditions. Okay, so we will be using FSM in order to create these conditions. Okay, that means when your robot, for example, is in ideal state and it should change from ideal state to some moving state, and from moving state it should move to some mopping state. So in this way, in order to change from one state to another state, it needs certain conditions. Is it or not? That means it won't move until and unless we are giving some order or we are giving some condition for it, right? So this conditions is nothing but FSM. So we can simply call FSM as it's like some set of rules. Okay, some set of rules which make the robot to decide which work to do or from which state it should go to another state. Okay, so all this come under FSMs, right? Hope you are clear about this FSM. Okay, so just like as I said, it is just a set of rules or conditions which makes the design that you are designing to work. Okay, so this is about FSM. So in Verilog, FSMs are widely used to create and control the systems. Okay, in order to control any system or in order to model any system with certain limited conditions, we will be using this FSMs. As I told you in the starting itself, we'll be using it in many protocols or many user interfaces or in as this example while we are designing any robotic systems. So in all these things we will be using this finite state machines. Okay, so they provide the structure and systematic approach for your design. Okay, so whatever you're designing, it will be creating the structural and systematic approach so that everyone can easily understand. Because whatever ultimately, whatever design you are going to design, or whatever circuit or something you are creating, it should be for the use. Or else, is it or not? It should be for the real time usage. So when the particular design, or when the particular for example this cleaning robot, when it will get succeed only if everyone can understand it easily. So your FSMs will be making that process easy. Okay, in order to analyze any design, or in order to structure any design in a particular systematic way, FSMs are very useful, right? Hope you got a clear idea on what is FSM, right? So as I told you, so this is some protocol, like this is a APB protocol, if you see here. Okay, so in this APB protocol I'm just giving a basic idea. Okay, while I'm explaining about these protocols, I'll be explaining clearly about what is this FSM and all. In this way the conditions will be, see, presently the say is in the protocol, the transfer is in ideal state, and only when the selection is 0 and t enable is 0, only then the transfer will be taking place. Then it will be going to the next state called setup state. So it is having three states: ideal, setup, and access. Okay, so based on selection and enable input, the states will be changing from one state to another. Like it will be changing from ideal to setup, and from setup to access. Again from access also it will move to either period E or else anything. So based on the states, based on the sequence that you are giving, it will be moving from one state to another state. So these are called conditions. Okay, so hope you got an idea of what is this. So, as I told you in the starting, what we are going to do here, we are going to write a Verilog code for FSM. Okay, so for this, what we are going to do, we are going to take a sequence. Okay, let us take the sequence 1010. Okay, so this is my sequence. So before going into drawing a state table and state diagram for this sequence, firstly, as I think you already know about this, so FSM is categorized into two parts, which is Mealy and Murray. Okay, so based on the usage of, you can draw the state diagram, or you can write the state table in any of these two FSMs, like in any of these state machines, like Mealy state machine or Murray state machine. It's your wish. Again, in Mealy and Murray also, they are having again two types, like overlapping and non-overlapping. Okay, so overlapping states and non-overlapping states, you will be seeing what is this overlapping and what is this non-overlapping state, right? So today what we are going to see is, we are going to draw a state diagram for this sequence 1010 in Mealy, state machine. Okay, so we'll be using this Mealy state in order to detect this sequence 1010. So since it is Mealy, you already know the difference between Mealy and Murray. Okay, if you don't know about the difference between Mealy and Moody state machines, okay, you can ping me so that I'll explain that clearly. But as for now, I don't want to explain about the differences and all, because as I told you, I don't want to give in deep concept about this FSMs, because what we are trying to achieve is, we are going to write a Verilog code by using this FSM. So in order to write the Verilog code, you should know about the state diagram and state table. So that is why I am explaining the state diagram and state table before writing a code for this particular FSM. Okay, so this is my sequence. So 1010. So it consists of 4 bits. Since this is the Mealy state machine, so how many bits that are present, those many states only will be present. So since 4 bits, you will be having 4 states. Okay, let us consider those 4 states as A, B, C, and D. Okay, so these are the 4 states. Since 4 bits, 4 states. So presently it is an ideal state. Okay, as soon as you give reset, then it will be everything will be set to the default values and all. Now coming to the sequence. So whenever the A value, okay, A state receives 1, Okay, that means here 1, right? The first bit is 1. So whenever the A receives 1 bit, okay, then it will be moving to the next state B. Clear? Yes, so we are mentioning it as A. 1 by 0. What is this 0? So this is input. Okay, this is output. Why input is 1? Because only when input is 1, it will be A will be moved to B. If input is not 1, then A won't be moved to B, because that is the sequence condition that we are getting. 1 0 1 0 is your sequence. So in order to move your sequence, the A bit should be 1. Okay. So when A receives 1 bit, then it will be moving to B. But 1 is not the only output. Here, as until 1010 sequence is detected, the output won't be activated. So that is why the output is 0. Right? Clear? Yes. Now what happens? B has received 1. Now, until B receives 0, it won't be going to C. So that means B value, whenever B value is 0, when B receives 0 bit, then it will be going to C. Similarly, when C receives 1, it will be going to D. Just like that, when D receives 0, then the output will be activated. Clear? Okay, hope this is clear, right? I'm explaining it one more time. So when A receives 1 bit, okay, then it will be moving to B. And when B receives 0, because after 1 it is 0, so when B receives 0, it will be moving to C state. And when C receives 1, it will be moving to D state. And when D receives 0, then the output will be activated, like the output will be 1 until the last state is 0, the output won't be 1. Clear? Yes. So this is all true cases. That means when A receives 1, then it will be moving to B. When B receives 0, going to C. When C receives 1, going to D. So this is all case that when your sequence is just 1010. Okay, you have designed the state machine for 1010, and the input that you are giving is 1010. Okay, so all true cases you are giving for this sequence, so it is fine. Now for example, if you are giving 0101 as your sequence, okay, so what happens? That means you have given all the false cases. Now what happens? Okay, that means when A receives 1, it will be going to B. If not, that means when A doesn't receive 1, because it may be either true or false. So when A receives 0, then what happens? If A is 0, then it will be staying in that particular state itself. Okay, that means it will be in A only. So that means when A receives 0, that means when A is 0, it will be staying in that particular place. Clear? And when A is 1, it will be going to B. Now similarly changing to, going to in the sense it will be changing from one state to another, then the A value is changed to state B. Okay, now coming to B, right? When B receives 0, okay, it will be going to C, or it will be changing to C. But if A receives 1, then what happens? If B receives 1, then it will be staying in that particular state. Okay, that means if it is 1 by 0, then it will be staying in that particular case itself. Now if you see here, if here A value is 0 and when B is 1, then it will be going to it will be staying in that particular place. Now coming to C. Now if C is 1, then it is going to D. If C is 0, then what happens? If C is 0, it will be going to the state where 0 is present. Where is the state with 0? Here A is the state which is the 0th position. So then it will be going to A. Okay, when this happens? When C is 0. Okay, that is when input of C is 0. Okay, now coming to D. Okay, when D is 0, it will be giving the output 1 and it will be going to the home place. When it will be going to the home place and all, we'll be seeing that. But as for now, just take it like this. Okay, when D is 0, then the output will be activated, like the output will be because it has received the entire sequence, because here the sequence is 1 and here the sequence is 1 0 and here the sequence is 1 0 1, here the sequence is 1 0 1 0. So it has the entire sequence that we are designing. So that is why it has activated the output as 1. Fine. If D is not 0, that means if D is 1, then what happens? Then it will be going to the place, or it will be going to the state which has 1. Now if you see here, what is the state that is having 1? B. So it will be going to D. Okay, when D is 1, and here the output is 0, because here if you see, if you are getting 1 0 1 1, that means here you should get 0 in order to complete the sequence. But if you are getting 1, means the sequence is broken here. Okay, so since it is broke, it will be going to the previous where the particular one state is there and the output is still 0. Okay, again from here the sequence will be starting. Clear? So this is how the sequence is. This is the state diagram of Mealy state. Now coming to D. Okay, here as I told you, if D is 0, then it will be giving the output 1. Then what next? Okay, then again it should start another sequence. Is it or not? Okay, only this won't be your sequence. Is it or not? So your sequence will be like this. For example, in this way, it is in a continuous manner. So now what happens after completion of one sequence? It should go somewhere, or it should start somewhere. Okay, in at this point of time you will be seeing the difference between overlapping and non-overlapping cases, because in overlapping case what happens means, okay, in overlapping case, based on the previous state, okay, based on the previous values, it will be going to the states, whereas for non-overlapping case it will be going to the home state, like A. Again it will be starting from A. Okay, here this is 0 by 1. This happens when only when it is non-overlapping. Okay, only when it is non-overlapping, then again after the entire sequence of 4 bits is detected, again it will be starting for the next 4 bits. That means after this is selected, again these 4 bits need to be taken care of. So for these 4 bits, what it will take, again it will start from A, and again the sequence will be like 0 1 1 1 0. So this sequence will be detected. Okay, but when this is an overlapping sequence, what happens means, for example, you are taking like this, okay, some 1110. So this is your sequence. Okay, this sequence is detected. Fine. So 1010. Now what happens after detecting 1010? So for the overlapping sequence, what happens means, it will be checking the previous bits. Like if you see here, 1010, this is my sequence, one sequence, it is fine. And if you see here, this is my second sequence, okay, 1010. So what happens, it will be taking, or else if you see here, if this is starting from here, if the next sequence is starting from here, then it will be checking the previous states where the sequence will be starting. Like since it is 10 starting, it will be taking from here. Okay, so then what happens, the D will be going to the previous state where the 10 place is there. Like here if you see, from here it will be going to B for overlapping cases. Okay, hope you are clear about this. Okay, if you have any doubts you can ask me, right? So for this state diagram we are going to create a state table, right? So this is the state diagram. Okay, for this state diagram we are going to write a state table. So based on this state table only we are going to write a code for FSM. That is why state table is important. So you all know how to create the state table, like you will be seeing present state, next state, and you can write, you can also create for output also, right? So what are the states, present states? I have taken A, B, C, D. Any names you can take. It's not only A, B, C, D, anything you like. So these are the present states. Now in order to move to next state, it should depend on input. Is it or not? The based on the input value, whether it is 0 or 1, based on the dependence of that only, it will be moving to the next state. So based on the x value, like if x is 0 and if x is 1, so if x is taken as input, like if you are taking this as x, then based on if it is 0 or 1, the state will be taking place. So if it is 0, what happens? It will be in a only, so the next state will also be a. Now if it is 1, it will be going to b. Okay, similarly for b, if it is 1, it is staying at b, and if it is 0, it is going to c. Okay, similarly for c, if it is 1, it is going to d. Okay, and similarly if it is 0, okay, it is going to a. Okay, and here at d, what is happening? If this is like 0, yes, if this is 0, then it is going to, if it is non-overlapping case, then if it is 0, then it is going to the original state a. Okay, home state. Okay, and if it is not 0, that means if it is 1, then it is going to b state. Okay, so and coming to output also for x equal to 0, x equal to 1, because here if x equal to 0, there is change in output, so that is why. But if you see here, all the outputs are 0 only, so all the outputs are 0. When the output will be 1? When x equal to 0. So when x equal to 0, the output will be 1, or else the output will be 1. Okay, or else the output is 0. Clear? So this is how you will be creating the state table for this particular Mealy state. Clear? So hope you are clear about this particular FSM. Okay, if you are still having any doubts, okay, you can ask me. And here, if it is for example, if this is for non-overlapping, this the state table is like that. For example, if this is overlapping state, what happens? Everything will be same almost. Okay, but where the difference will be, here in the D state, if x equal to 0, it is moving to x equal to 0, it is moving to C. Okay, and then it is going to, or else if x equal to 1, then again it is moving to B. Clear? That is 1010 is my sequence. So this is my particular state diagram for that particular sequence 1010 in Mealy. Okay, Mealy, and it is non-overlapping case. Okay, for overlapping case, the entire state diagram is same, except that here it will be, instead of A, it will be going to C. Okay, since it is overlapping. Okay, this C will be for overlapping, and if it is non-overlapping, then it is A. Fine. So this is the state table for that particular sequence that we have extracted from the sequence 1010 for Mealy FSM. Okay. So when we are writing a code for this, okay, so module, any sequence detector name. Okay, so what are the inputs? If you see here, clock, okay, reset, because in order to make it activate, and in order to, based on the clock only, the sequence will be detected. So clock, reset, and if you see here, x is the input. Okay, and the output is named as z, right? So the z is the output, and here we are taking four parameters, right? A, B, C, D. Since here if you see, these A, B, C, D are the states. Okay, these are neither inputs nor outputs. Okay, so these are just like constants. Okay, if you are familiar with parameters, you know that parameters are nothing but they are the constant values which will be described within the module. Okay, once you have declared the parameter, then it will be globally worked for your entire code in your program. And if you want to place the value, or if you want to override the value of the parameter, you could only do it by using the defparam keyword. Okay, I'll also explain about parameters in the next session. If you are not familiar with parameters, you can go check it while I explain about the parameters. Okay, but as for now, remember that parameters are just like constants. Okay, right? So since there are neither inputs nor outputs, we have mentioned, if you see here, clock, reset, and x are inputs, z is output, but we are declaring the states which are neither inputs nor outputs, so we are declaring them as constants. for declaring the constants, what can we do in the Verilog? We can use the parameter. Okay. So A, B, C, D are my parameters, and I am declaring some values for these parameters. Okay. Like which is hexadecimal format and 4 tick. Okay, 4 tick H, 1, 2, 3, 4 are these values for these parameters A, B, C and D. Okay, and then I am taking, okay, some bits. What is it? That is state. Okay, present state or state, both are same. Okay, either PS or state, right? Either NS or next state. So I am taking these two as, because by using this table only we are going to write our code. So we should take this states. Okay, present state, which is state. Okay, and then next state, and both are of 4-bit wide. Okay, clear? Yes. Now I am writing my code. Always at the rate positive of clock or negative of reset. That means in order to detect this sequence, okay, we are going to write our code. So how should the sequence, where, as I already told you that the sequence will be working on based on the clock. Okay, so that is why we are activating our clock and resets here. So always at the rate positive of clock or negative of reset. Okay, so you already know whatever we are going to write the sensitivity list within the always block. Based on the sensitivity list only, the always block will be activated. So this always block will be activated whenever there is change in clock or else negative of reset. That means whenever the clock is in positive edge or reset is in negative edge, then only this block will be activated. Okay, what have I written in this? I have written some conditional statements. If you see, if not reset n, that means here what is this? If reset, in the previous class I have already told you, okay, when you are giving the reset, then all will be having the default values and the sequence will be starting as soon as you are giving the reset. So that is why if you are not giving any reset, it will be staying in that particular position A only. Okay, it won't be moving to the next stage until you are giving it activating the reset. So if reset is not activated, then the state will be remaining in A. Okay, if reset else, okay, begin and end. Okay, and then else, if not reset, that means if reset is activated, then it will be moving to the next stage. Okay, clear? Yes, this is how you will be activating your the reset and clocks. And then coming to the next block, so always at the rate. So how the changes, how the changes will be taken place, like how the movement will be done from one state on the state, how A will be going to B will be going to C, and C will be going to D, based on the bits. Is it or not? Based on X values. So always at the rate X or state. Okay, that means what is the state? What is the present state? So based on the present state, that means here if it is in A, then it will be moving to B. If it is in B, then it will be moving to some A or D again. So based on the present state and X, we should be writing our code. Okay, now always at the rate state or X begin, right? So case of state. Okay, so what am I doing here? I am writing a case statement. Okay, for this case statement, what am I taking? I am taking the state. Okay, so what is the state here? A, B, C, D. So these are my states. So whenever A is activated, so depending upon the input values, the change will be taken place. So case of state, right? A, right? So A, what is the condition that I am writing in A? Begin. Okay, if X equal to 0, okay, the next state will be A. Okay, else it is B. Okay, next state will be B. Similarly for B, that means this, for this state I am writing this condition. For the second state B, see, if X equal to 0, next state is C, else next. Similarly we will be writing for another two also. Have you seen this? If X equal to 0, this, else next state is D. Similarly for D, If x equal to 0, next state is A, else next equal to B. Here, if you see, I have given some comment here. If you are reading this state only differs when compared with Mealy overlapping machine. Okay, that means in case of non-overlapping, here the next state will be coming for A. Okay, but in case of this, if you see here, in case of overlapping, it will be going to C. Okay, so that means what happens here, in case of this, you will be going for C. Okay, default next state equal to A. Okay, these are the four cases. Else, if nothing of this will be true, then the default case will be activated, which is it will be only in that present state, which is A. Okay, so this is how you will be writing the case. So now what happens, based on the state that you are giving, like based on the input, so either of these four cases will be activated. Any one of these cases will be activated, and based on that the logic will be going to work out. Okay, now coming to output. Okay, we have written for, if you see, we have activated the clock and then we have written the logic. Now coming for output. So what is the, when the output will be activated, when the output is 1 here at the D state. Okay, when x equal to A, and when at x equal to 0, if this is A and B, and also at this stage at x equal to 0, it will be 1. So based on that you will be writing the logic. If you see here, assign. Okay, this is the data flow modeling. And if you see, you can use both data flow modeling as well as behavioral modeling, everything in one code. But what you should do is, after ending one kind of modeling only, you can start another kind. Okay, that means after ending the behavioral modeling, then you can go for data flow modeling. But you can't mix match before ending. You can't write this particular statement here. If you are writing this particular statement before ending the behavioral, then it will throw you error. Clear? Like assign Z. So what is the state there? A state at state equal to D. If you see here, this is my conditional statement, conditional operator. Okay, so I am writing the conditional operator here. What is my conditional operator? State equal to D. So until and unless these two statements are true, then only output will be 1. So what are the two statements? State should be equal to D and x should be equal to 0. Why? Because if you see the thing here state equal to D and at x equal to 0, then only the output is 1, right? So based on that you are assigning. So if these two are true, then it will be, output will be 1, else it is false. Okay, so you have written the RTL logic for this. Now in the test bench, you already know test bench is just used to pass the values. So module TB, again whatever you are mentioning as inputs are given as rich and output is mentioned as wire. Okay, and then this is instantiation. Okay, after instantiating you are activating the clock. Okay, initially clock value you have default set it to 0, and then always #5 clock equal to, that means here the clock period, the total clock period is 10. Okay, 10 time units. So for 10 time units you are creating the clock here, and then initial begin x equal to 0. That means initially you have defaultly you have created the value of x as 0, and then you have activated the reset at 2 time units, like reset n equal to 1. You have say, after activating the reset only your sequence will be starting to detect. So then for every time unit, after giving some delay, okay, some constant delay, you are passing the values. So in that means you are passing like 1 1 0 1, yes, 0 1 0. This is the sequence that you are passing. Okay, like 0 1 1 1. This is how you will be passing the values. Okay, and after passing some string of values, you will be giving the dollar finish and end. Okay, and then within this initial and begin, you will be, in order to see the waveforms in the EDA playground, you have to use this file, dump file. We'll call this as dump file. Okay, if you want to see the, actually when we are executing it in the EDA playground, you will be seeing in the log file, you will be seeing the output in the text format. But if you want to see it in the waveforms format, you should be using this two statements, like dump file, we dump vcd, okay, dump varies. Okay, so this is how you will be writing your code. Okay, this is the test bench RTL and test bench code for this. Okay, so in the next class or in some other class, I try to execute this FSM on the EDA playground, because many of you are complaining me, like commenting me that on the EDA playground you can't see the code clearly. So that is why I thought of clearly explaining this FSM code to you on some other platform instead of EDA playground, so that it could be easily visible for you. So that is why. And also I want to explain it to you in parallel with the state diagram, sorry, state table. So that is why, based on the state table only, if you write the program, it will be easily understood for you, and also you won't forget it easily if you are comparing it parallelly as well as writing the code. So because of this thought only, I have taken this on the word, and I try to explain it to you in the word document, so that by seeing the state diagram, if you write the code, it will be easy for you. Okay, hope this video is helpful for you. And if you like this video, please like it, share and comment. And also, if you are new to the channel, consider subscribing the channel. Thank you.